Hey everybody, today we're going to talk a little bit about compound inequalities. I'm going to walk you through some examples here. So there's two types of compound inequalities. There's or statements and and statements. Alright, and statements also are known as conjunctions. And what that means is that two things need to be true. Right? Or statements called disjunctions, where only one of them has to be true. And you'll see in a moment once we get to it. So here we have an example of an or statement, also known as a disjunction, where we're going to graph both number sets because they're both part of the solution. They don't have to see what's in common. And statements, you're basically going to see what they both have in common. An or statement, you just put them both on the same number line. You're essentially just graphing two inequalities on the same number line. So let's rewrite this. We have a over 2 is less than or equal to negative 4, and a plus 1 is greater than 7. We're just going to solve each one. So let's go ahead and solve for a over here. So we're going to use the inverse operation. We're going to multiply by 2. So we're going to get a is less than or equal to negative 8. Or, and over here we're going to get rid of this positive one. We're going to subtract 1. Oops. Subtract 1 from both sides and use the inverse operation, which is subtraction. So a is greater than 6. So it's both these things. It's going to be this or that. So we're not looking to see what they have in common. It doesn't really matter what they have in common. We're just going to draw both of them on the number line, or represent them rather. So we're going to do a is greater than 6, so it's non-inclusive. A is greater, so we're going to the right. A is less than or equal to negative 8, so that's going to be inclusive, so it's a filled-in circle. And a is less than, so it's going that way. And there you go. That's how you do number 1. Let's look at number 2. So we have b plus 5 is greater than or equal to 12, or b over 8 is less than or equal to negative 1. Okay? Well, let's subtract 5 from both sides. Oh, it's the wrong color. Subtract 5 from both sides. Okay, and we're going to have b is greater than or equal to 7. And over here we're going to multiply both sides by 8. And b will be less than or equal to negative 8. Okay, that's an or statement. So this is a disjunction. So b is greater than or equal to 7. So 7 would be, let's see, oh, this is a little interesting. So let's see, 4, 2, so this is 6, so 7 would be right here. That's kind of confusing, the way they did that. Filled in circle, it's greater than, so we're going to the right. And then b is less than or equal to negative 8. So this is also inclusive, going that way. So I guess you'd have to be careful whether you graph that. It's not the best way to do it, I guess. Okay, here we have another or statement. So negative 10 n plus 4 is less than negative 16, or negative 6n minus 8 is greater than 40. Okay, so we're going to subtract 4. We're going to have negative 10n is less than negative 20. We're going to divide both sides by our coefficient, which is negative 10. And remember, because we divided both sides by negative, this inequality symbol is going to change, so this is going to become n is greater than, and negative 20 divided by negative 10 is positive 2. Okay, so here we go. We're going to add 8 to both sides. Negative 6n is greater than 48. Negative 6, negative 6. All right, we're dividing both sides by negative 6, which is our coefficient. And this will change, so n will become less than negative 8. That's an or statement. Okay, so n is greater than 2. Open circle, greater than, going this way. N is less than negative 8. So it's going that way. And they're both non-inclusive. Alright, let's try out this one. And these are all or statements. There are some and statements on the other side. I double-checked, so we do get to do some of those. So 10 plus 6n is greater than 46. Or negative 3n minus 8 is greater than or equal to 4. So we're going to subtract 10 from both sides. And we're going to get 6n is greater than 36. And then we divide by our coefficient, which is 6. So we have n is greater than 6. And over here, we're going to add 8 to both sides. And we're going to get negative 3n is greater than or equal to 12. Let's divide both sides by negative 3. Okay. And and this is going to change direction now because we divide by a negative. So n is less than or equal to negative 4. Okay. Alright, that's pretty sweet. Yeah, that worked. Okay. So now we're going to graph this. So this is an OR statement. So it's a disjunction. So n is greater than 6. So it's non-inclusive. And then this is n is less than or equal to negative 4. So it's going to be inclusive. And we're going that way. Alright. Let's try the backside here. So here's our first AND statement, and this is written in an interesting way that sometimes confuses people. So whenever you see a compound inequality written in this way, you're going to rewrite it twice. You're going to say negative 1 less than or equal to m over 10, and m over 10 is less than 0. So we're going to get m by itself by multiplying both sides by 10. So 10 times negative 1 is negative 10 is less than or equal to m. And over here we're going to multiply both sides by 10, and we're going to get m is less than 0. Yeah. Okay, so this is the AND statement. So we're looking to see what they have in common. So I'm actually going to use a pencil for this one. So AND's important. We're going to see what they have in common. So m is greater than or equal to negative 10. So I'm going to graph that separately first, and then m is less than 0. So you can see this is the area they have in common from here to here. So our answer would actually be open circle here, yeah, and that would be our solution right above that, because you can see it's the common area, or in other words, the overlap. Probably the best way to think about it when it comes to AND statements, because where these two solutions overlap with each other. Let's try another one here. So we have m over 6 is greater than or equal to 0, and that's what we call a conjunction. And m minus 6 is less than or equal to negative 4. So we're going to multiply both sides by 6. We're going to use the inverse operation. M is greater than or equal to 0. And then over here we're going to add 6 to both sides. So we're going to get m is less than or equal to 2. And that's an AND statement. So m is, let's use the pencil again. So m is greater than or equal to 0. So inclusive, and then m is less than or equal to 2. So you can see this is the area they have in common, so it's going to be from here to here, and they're both inclusive. And that's it. Alright, let's try the last two. Okay, so we got negative 2 minus 6x is greater than or equal to negative 56, and 6x plus 6 is greater than or equal to negative 6. Okay, so we're going to get rid of our constant here, so we're going to add 2 to both sides. So negative 6x is greater than or equal to negative 54. We're going to divide both sides by negative 6. And we're going to change the direction of the inequality symbol because we divide both sides by a negative. So x is going to be less than or equal to positive 9. And this is an AND statement. And we're going to subtract 6 from both sides. 6x is greater than or equal to negative 12, and now we're going to divide both sides by our coefficient. Okay, x is greater than or equal to negative 2. Okay, so again, I think using the pencil for these is a good idea. X is less than or equal to positive 9, on that way, and then x is greater than or equal to negative 2, and you can see where this is going. So it's this area here. So we're going to say between negative 2 and positive 9. Close circles. There you go. You can erase those and rewrite if you want. I'm just going to keep them both so you can see them both. Alright. Down here, our last one. So we have negative 13 is greater than 10r minus 3. And again, this is written strangely, so you write it like that, and then you write it like that. And 10r minus 3 is greater than or equal to negative 63. Alright, so we're going to get rid of our constant first. We're going to add 3 to both sides. Negative 10 is greater than 10r. Divide both sides by our coefficient, which is 10. Negative 1 is greater than r. And add 3 to both sides. 10r is greater than or equal to negative 60. divide both sides by our coefficient. R is greater than or equal to -6. Excuse me. Alright, so R is less than or equal to -1. Sorry, just less than, not or equal to. So it's non-inclusive. And then R is greater than or equal to -6. So it's going to be closed circle here, and then open circle here. That's our answer. Alright, so hopefully that was helpful, guys. The main thing is just really like the others, just take your time and show your work, right? Let me go ahead and flip it over. Alright, let's trim out a little bit more here. There we go. Alright, let me know if you have any questions, guys.